is all about rational expressions.
Why is it so
It's all about rational expressions. We've heard the word rational before. We used to call them rational numbers. Who has any idea or remembers what a rational number is, Calvin?
Terminating decimal.
Yeah, it's a decimal that ends or repeats. Okay.
Or just like a whole number, no?
Yeah, or it's a whole number, which means you can write a rational number in a fraction. That's what a rational number is. It's a fraction. So rational expressions are the same thing. Except now, instead of numbers, we're going to use letters. So, rational number, right here. That's a nice example of a rational number. This thing. Rational expression, same thing. Except now, it looks like that. A rational number is anything that can be written as a fraction. Can be. And we've always said it's a terminating decimal or a forever repeating decimal. It just so happens that that's what a fraction does. Fractions always end decimals, or they always repeat decimals forever. So like 1 over 3 is 0.333333 forever, right? It's this repeating decimal forever.
Can you put
No. So pi is an irrational number. We don't need to get caught up on the number system so much. All I wanted to get caught up on is rational expressions are just expressions that are fractions. You talk a lot about pi. You talk a lot about it. That's a whole unit thing. John. Right, but then okay. See, with rational expression, what we're going to focus so much on is there's times when rational expressions don't work. In math, there's a special rule. There's a couple special rules. One is that you can't square root a negative, right? We've learned that. Another one you learned a long time ago was you can't divide by 0. It's not possible. Division is like breaking things into groups. So if I have 2 people and I break them into 0 groups, it doesn't make any sense. Where do those people go? Are they part of one group by themselves still? Do you have 0 group of 0? Yeah, that's why it doesn't work. It doesn't make sense. This whole lesson, based on dividing by 0. You're going to have to learn how to write domains and ranges and stuff like that for these types of equations. So, if we're looking at this right here, x plus 5 divided by x minus 3, that's a rational expression. If I ask you, what's the domain of that expression? X could be anything, right? I could pick negative a million, plug it in, and it would give me some answer. The only time it doesn't is if I divide by 0. So what number wouldn't work? 3. Because if I put 3 in for x, I get 8 divided by 0. If I put that on my calculator, I get error. We call those non-permissible values. The value that x can't be. So the non-permissible value here would be x cannot equal 3. That's the rule that that expression must follow. X can be anything else it wants to be, can't be 3. If it was really, really close to 3, still works. But it can't be exact. So, look down at this next one. what would be my non-permissible values? OG. Yeah, if I put -7 into this first one, I get 0. 0 times 0 is 0. Can't do division by 0. If I put a 3 in, 3 minus 3 is 0. 0 times 0 is 0. 0 times n is 0. Can't divide by 0. So your non-permissible values, or your restrictions on this, would be x cannot equal -7 or 3. Yeah, so it depends. If the question is what is the non-permissible values, probably just 3 and -7. But a lot of the times you say what are the restrictions, and you would say x cannot equal -7. Okay.
So to find it, you just make whatever something zero.
Exactly. You find what value of x would make the bottom 0. And right now it looks really, really easy. What form does that look like? Factored form. Factored form is a great form to tell us what zeros are. But we're going to start getting questions that aren't in factored form. Grab one of each of these. And actually, yeah, just turn this to this right. That's the key to everything. It's like, it is that easy. If you can make the questions that easy. So factoring is going to be a big part of this unit. If you're weak on your factoring, you should probably just come get some factoring review. You should come ask me, say, Kennedy, I can't factor. Help. Okay. This should be quick and easy. It's going to say, where are these things defined? So what are the domain? If it asks you when is something defined, it's asking for a domain or a range. This first one, what's the domain? Remember the domain that is saying what x value is going to be. Julie?
Greater than 0 or less than 0.
It could be greater than 0 or less than 0. It just can't be 0. So how would we write, imagine if you could divide by 0. How would we write that? It could be any number. You could say XER. We do the same thing here. We say, yeah, x can be anything you want. But x can't equal 0. That would be your domain. This first chunk is saying x is an element to the real. X can be any number you want. The comma means but x can't equal 0. Because you can't divide by 0. Not possible. The second one, 10x. What would our domain be for that? Any real number. So this one's just going to be x is an element to the reals. Exactly. If it's not a fraction, you're not going to have any restrictions. What about this next one? 3 plus x. XER. What about this next one? 5 divided by x. XER, but x cannot equal 0. Yeah, 5 divided by x is the same thing as 5 over x. Same thing, written in a different way. Josh. That's the concept behind everything we're about to do. Kyle.
Is there a reason why you don't just, like, it's simpler to go 5 divided by x than 12 over x?
I think this just looks neat. I think that's the only reason we do it.
Is there, like, no other reason?
Same reason they use a dot for multiplication instead of an x. I think it just looks better.
So you can, like, almost rewrite it with
What?
Something it's easier to write like 5 over 3x than it is to write bracket 5 divided by 3 times.
There's no real reason. No logic.
Now, does the student just based on what x can do?
A lot of it. It's going to be based a lot on what x can and can't be.
an XD equation that you
Exactly. So we said earlier that those other ones were really easy because they were in factored form. So change them into factored form. And you're going to have to because of where we're headed. So you might as well just get used to it. So if you look at this equation, I say, what's your domain? And you look at that and go, I don't know. Like, it's too hard to tell what's going to make that 0. So factor it. So factor that bottom. We're just factoring the bottom. Things that multiply to be -6 and add to be -1 are -3 and 2. So I can factor the bottom of this to be x squared plus 2 divided by x minus 3 times x plus 2. I just factored the bottom. Now it's easy. Now it's in the exact same form as those last ones. So what's the domain of this thing going to be? It's going to be XER, but what? But x can't equal 3 or -2.
So the top equation is like a completely separate one than the bottom.
Right. The top is its own thing. We don't care if the top is 0.
So that's why it's XDR.
Exactly. Just the bottom we care about. You just can't divide by 0. You can have 0 on the top. If I have 0 things, and I divide it into 100 groups, I still have 0 groups. Because there were 0 things to put into those groups. Exactly. That still makes sense, right? The other way doesn't make sense. That.
We're doing these things, we're solving them by just giving them like ranges.
Yeah. Domain. They're just asking right now, what's the domain of these things? What values of x worth? If you graph that, it's not very great. So, in your graphing calculator, once you graph it, make sure you use brackets. Okay, so put brackets around things on the top and put a big set of brackets around the thing on the bottom so that your calculator knows to do those things. Almost your graphing, you should have got, and like I said, it's going to look different on different calculators. So, it should have looked something like this, depending on your window. If you had your window at -10, +10, -10, +10, you should have got something that looked pretty similar to this. Some of you have extra lines. Your extra lines are right here. Those extra lines, they mean something. Those extra lines they make it look like everything's connected, which is why they took them out of some of the calculators, because it confused people. Because they're not part of the graph. Those extra lines are at -2 and 3. They're at the values you can't beat. Those extra lines are things that the graph will never touch.
So you just graph it and then figure out what the lines are, it tells you.
It tells you. But the problem is if it won't say what you can't calculate the line. Your calculator can't do that.
You can just push the arrows.
You could get close enough to probably make a good guesstimation.
Why can't you just do like
The what? The 0 calculation of the bottom? Of just the bottom?
No, like to find the X and figure out where the we're not looking for it.
Oh. Okay. Okay, yeah. So if you're just looking for these lines, for where x can't equal something, there's lots of tricks. You could do that. You could graph it and then move your calculator over so you can't get it anymore. Right, that won't give you an exact value. It's the one downside of that. You could do what Emily is suggesting, which would be you're just going to graph. So she's got it right, but I think she's a little bit off on what she's graphing. If you graphed just this, what I circled in green there. You graphed just that and calculated your x-intercepts.
Oh,
That's your zeros. That's what we just did here. So all of these topics link into each other. So if you know quick ways to do them, that's fine. Another way you can do it. You took this. You want to find the zeros, right? Where x is 0. You can use your quad formula on that. You use your quad formula. That would tell you x can't be 3 or negative 2. Lots of tricks. I'm always going to do the factoring way because of where we're headed.
and the clock is just a whole bunch of numbers. How would you get negative?
Yeah. That's why I avoid the quad formula, in all honesty. Because, one, you don't really need it. You should know how to do the long time math. And two, it confuses a lot. The one thing is, in a couple slides, you're going to figure out why factoring is so much more important. So yeah, you could find the non-permissible values of x using a lot of tricks, but you can't find other things using tricks. So you definitely want to do this one. Okay. I just wanted you to see what those graphs look like. That's never, you're not going to get tested on that. It is. You're safe if you don't get what that is. I just wanted to show you in case one day you go to graph to try to figure something out and you're super confused by what you get. That's just kind of inevitable. You tend to just graph things. Alright, let's look at this next one. X divided by x squared plus 1. We have to factor the bottom. We look at that, and you go, Kennedy, I can't factor that. And I would be like, yeah, you're right, you can't factor that. You can't dimension this. There's no b value, then it doesn't work. You can't difference of squares it, because there's no subtraction. And you can't take the greatest common factor out. So this is already factored form. Our goal is to not divide by 0. So we have to figure out when that thing is 0. So you go x squared plus 1 equals 0. You want to figure out when this will be 0. So solve for it. Subtract 1 from both sides. X squared is equal to negative 1. Square root both sides. X is equal to the square root of negative 1. Is that possible? That's one of our rules. So can this ever equal 0? No. So is there any restrictions on x? No. So x is an element of the real. Aaron.
Can I do like check like wouldn't it just give us the value as 0?
You could try.
1 and then 0 and then negative 1 plus 1 is
The negative 1 and 1 don't multiply to be 1. They multiply to be negative 1. So you're right. You could have tried the diamond method and put 0 in for b, but there's no numbers that work. So you're right.
But
That-
you can do that.
You can do it with other ones, yeah.
Is this a 2 marker? Like, would that be?
Every multiple choice question is 1. That would probably be a 2 marker, because I'd want you to state that, and I want you to prove it.
Take that, and then so same with like if I
Like this would be 2 marker. State the domain, you get 1 mark for getting it right, 2nd mark for proving it.
okay, yeah, so you have to state the whole domain and
Yeah.
okay, not just x.
You're not going to get questions like this is super basic. Like, your notebook is huge for a reason. Okay. This next one. Factor the bottom. Always. You have x squared minus 9. You go, Kennedy, I can't diamond method that because there's no b value. And I say, okay, fair enough. You can't take the greatest common factor out of that because you just can't. I say, fair enough. But you can do something else. What can you do? Difference of squares. This is the last time I'm going to write the formula for difference of squares out. So, the formula for difference of squares is you have something and it's a perfect square. So that means you could square root it and get a whole number. Subtract, because that's what difference is. another perfect square. You have that. If you wanted to factor that, it would turn out to be a minus b times a plus b. It'll always work out that way. It's called a difference of squares. So you're going to square root the first term minus the square root of the second term times the square root of the first term plus the square root of the second term. Flashback down to this question. That means we can rewrite that as 5x divided by x minus 3 x plus 3. That's called a difference of squares. That's how they factor. Now, what values of x can't you have? You can't have a negative 3 here. You can't have a 3 here. No, you don't have an x of 3 or negative 3. You're right, there is a negative 3 there. But you don't have an x of negative 3.
I just thought it was like, so down.
I see what you're saying. Yeah.
Well, anything times 0.
Got it.
I have a factory question.
Yeah.
It's probably goes back like a while.
That's okay.
I forgot. When x just equals 1, does it actually, because like when you're making your equation equal to 0, to find 3 and negative 3, does that just
So, if you're trying to figure out what makes that 0,
yeah,
x is just x.
okay.
It's anything. It could be anything. You're trying to figure out what it has to be to make it 0. Yeah. Okay, what's your domain of this question? Yeah. What's the question of this domain? Answer.
XCR comma and then the x.
X is now into the reals, comma, x cannot equal negative 3 or 3. It can equal anything else, but not those numbers. Try this next one. Try it on your own. See if you can figure it out. Factor the bottom, figure out what x can't be, see if you can write the domain properly. If you factored that. You should have got the bottom to be x minus 4 times x minus 4. Because negative 4 times negative 4 is 16. Negative 4 plus negative 4 is negative 8. I wrote it like that. You probably won't see it written like that. How would you see it written? X minus 4 squared. Okay. I go to write my domain. X can be an element of the reals. It can be anything you want. But it can't be 4. Are we happy with that? Are we happy with x not equal 4? There's 2 of those. Does that make a difference? No. A 4 here is the same as a 4 here. You don't add them, you don't subtract them, you don't square them. A 4 here is a 4 here. That would be your answer. Alright. This. I tried, oh, sorry, go back. Yeah, what's up?
What happens if I wrote it as minus 4?
X minus 4 squared?
Yeah.
Same thing. So what would make that, what would make x minus 4 squared equal to 0? You would square root both sides. Square root of 0 is still to 0, so it cancels that out.
Okay.
X minus 4, move the 4 over. X is negative 4.
That's one.
Or positive 4. Okay, this slide. I'm trying to incorporate more of these. These are slides that you can rely on if you're feeling really lost on your notes. All this is showing you what equivalent expressions are. Equivalent means equal, means they're the same. At the beginning, it shows you a nice, cute example, super easy using numbers. If I give you a number like 4 over 8, that's the same thing as saying 8 over 16, same thing as saying 1 over 2. You go on forever, right? There's a whole bunch of them. These are all the same thing. Those are called equivalent. These are equivalent fractions. We're now going to do equivalent expressions. So, looking at this example. I need to do an equivalent expression using multiplication or division. So I'm going to do one of each. An equivalent expression using multiplication, I could just multiply that 3 into the brackets. And I'd have 3x plus 6 divided by x plus 2 times x minus 4. Are these two things still the same thing? Yeah, they're the same thing. They look different, but they're the same thing. That would count as an equivalent expression.
You don't have to change the bottom.
Well, that would, no, like I changed the top, that's enough. You could multiply the bottom too, right, by itself. So you could go that times that and get a nice little quadratic. You don't need to. This is an equivalent expression on its own. It's different, but it's still the same.
If you were to, like, boil them into each other, how would you get to the factors?
How would you get back to factor? You'd have to factor it again. Alright. What's the point? Okay, that's a good question. A lot of your answers this student could look like that. Could look like that. It could look like it's in fact like quadratic form. It could be in any different form. Right? It all depends on how you got the answer and how I got the answer. And our brains don't all work the same. So for instance, M-Dog might have distributed those 3's in because she likes the way that looks. Me, when I was calculating my answer for the test, I might have left it like that because I like the way that that form looks. You need to be able to pick up on when that is the same as that. So you need to be able to switch back and forth. Be like, oh, okay, I have the right answer. He just factored a 3 out. Or you need to be like, oh, yeah, we have the same answer. I just multiplied the 3 in. So you can adjust. I just want you to know they're the same thing, different way of writing. Okay, this one. Now we're going to do it through division, which is a lot bigger of a deal. The multiplication, not so much. The division's a pretty big deal. X plus 2 divided by x plus 2. Those can cancel out. So that's the same thing as 3 over x minus 4.
So does it have to divide into both?
That's a great question. So, and it's something we need to definitely address. If you have multiplication, which we have here, it needs to just divide into one of the things being multiplied. But it has to be the whole thing. So I couldn't take just an x out of that. I have to take the entire x plus 2 out of that.
So everything has to be in brackets.
Yeah, so everything in the brackets has to come out of each other because they're multiplied together. If you have something added together, so let's say this, 3 plus x divided by x. I can't divide that because that x has to be able to come out of both things because it's addition. So addition and subtraction has to come out of both. Multiplication has to be the exact same as just one of the things being multiplied. Luigi. Yes. So if this was x plus 2 in brackets and then plus x minus 4, that wouldn't work because you don't have multiplication on the bottom. You have addition on the bottom. So what works with the top works with the bottom. It's good for the goose, good for the gander. Right.
If you add x plus 2 and then x minus 2, can that still cancel out?
Those would not cancel out, and that's great because that happens to us in a couple of questions. Okay. Now here's the big question. I told you that these two things are the same. Right? And I'm not a liar. They are the same. If you're looking at this, what's your non-permissible value? This one is x cannot equal 4. We'll go back to this. Now x can't equal 2 or 4. Negative 2 or 4.
Do you have to put X?
If I was asking the domain, you would have to. Yeah. So which one do I use?
Okay, so X bit.
If it's just this question right now, the questions a lot of the time are going to be write in simplest form, state the non-permissible values.
So you use X.
Always use the original. Always use it where you start. After you've manipulated things, you're messing up with what the rules are, right? This had the x equals 2 disappear. Now it can be 2. But if you go back to the actual original question, x couldn't be 2. You need to include that. Talk.
I still can't like see how you got the 3 over X plus 4.
That x plus 2
Yeah.
divided by x plus 2 is what? 1. So 3 times 1 is left on the top. 3 times 1 is just 3. That's why the 3 is left by itself. Good question, Tom. Alright.
For that other one, the simplified form, can X now be negative 2, or can it still not be negative 2?
If you had just this question, right, you would say x could be negative 2. But the thing is, this question came from this. So for this, the restriction is still, it can't be 4 or negative 2. Because the restriction from the original has to stick with it. So, okay.
You're multiplying by the big thing. If you just multiply the bottom instead.
Yeah, for sure, if you want to. Okay, try this second one on your own. I want you to write 2 equivalent expressions, one through multiplication, one through division. So on the board, I've written 2 equivalent expressions. The first one, I multiplied the top and put it back into general form. You could have done anything else. You could have done the 2 in, you could have had on the bottom 2x squared minus 2, and that's still right. You could have multiplied the top and the bottom both by 100, and that would still be right. As long as you didn't change the actual value of it, you're good. Really.
I did the bottom one. I next to the top one as well.
Just the one. Just the one is fine. I just wanted you to get used to seeing that it's still the same thing. Yeah, do both, you're still good. Okay, the second one, x plus 5 divided by 2. That's really the only answer you could have got. X minus 1 and x minus 1 cancel each other out. Ooh. Like that. Leaves you with x plus 5 and 2 and 1. Yes. Alright. Write each expression in simplest form. If I give you a fraction, I give you 5 over 10. I also give you 50 over 100. I also give you 2 over 4. And I also give you 1 over 2. These are all equivalent. Agreed? They're all 50%. Either way, you barely pass. Right? Pass the pass. C get degrees. Okay. Did I ever tell you that story that that's the same? You C's get degrees in university because that's what you need to get a degree.
Yeah,
So
go to the class themselves, they just check if you have a degree.
they don't really check the mark. Yeah, they don't. They just want to see that you got the degree. That's all they really care about. So anyway, I thought in my first year, I thought the same as D's get degrees. So I just figured D's were good because it still made you were passing, right? Because F is a fail, D is a pass. Turns out that's not the same. C's get degrees. So you need to have a C average, not a D average. So after my first semester, and I checked my transcript, and they were like, "You're getting kicked out of school." I was like, "Whoa!" But D's get degrees. And my brother, who was living with me, is like, "You're an idiot. That's why you got D's." Like, makes sense. So, yeah.
Well, that's like my sister in Toronto. That's what she lives her life by.
Yeah.
Because she's getting degrees.
That's what- yeah.
That's
All university, like, that's the
the
same.
rodeo with like horses over men. All of them.
Okay. If we look at these, they're all the same. They're all 50%. Which one's the simplest form? 1 over 2. And we should be good at that. I mean, we've only been doing it 12 years. Right? That's simplest form. Why is it simplest form? Smallest number. There we go. That's the answer I'm looking for. You can't divide anything else further. That 1 can't be divided any further. That 2 can't be divided any further. That's what we need to do with our expressions. So, you're going to divide like terms. Coefficients divide with coefficients. X's divide with X's. Y's with Y's. Z's with Z's. 15 divided by 20 in simplest form is 3 divided by 4. 5 divided by 20. If you didn't know that simplest form, put in your calculator, math bracket. Now do your letters. What's x squared divided by x going to be? 1x. Yeah, you just subtract the exponents. What's y divided by y going to be? It's going to be 1, so you just leave it there. You don't put anything in. What's z cubed divided by z going to be? Z squared. That's simplest form. That's a good question. You can, but we don't have that question here. If you had z divided by z squared, you subtract the exponents, which is right, but 1 minus 2 is negative 1. So to get rid of the negative, you leave it on the bottom. So it would be 1 over z. So if you have the larger exponent on the bottom, you leave it on the bottom. If you have the larger exponent on the top, like we had here, the variables all go on the top. Yeah, that's basically exponent 1. You forgot them? If you're multiplying, you add. If you're dividing, you subtract. That's all you're doing.
The ones that I get confused is when you get negative.
Negative?
Hours.
Those are always the hard ones. Okay. We're looking at this. There's 2 ways to do this. Way 1. You realize that you can only divide if it goes into everything. Way 2. Factor the top, divide out anything where there's multiplication. So if I factored the top, I would take an x out of it. That's the greatest common factor, right? So x comes out, 3x minus 8 is left in. On the bottom, you have 2x. To me, that makes sense. And I understand to a lot of people that doesn't make sense. So I'll also show you the other way. Right now, I have multiplication, and I have multiplication on the bottom, which means I can cancel things out if they entirely cancel out. Can I cancel out a 3x minus 8? No. Can I cancel out an x and an x? Yes, because that's multiplication. So those can go away. So my final answer would be 3x minus 8 divided by 2. Can I divide that 2 out of everything? No, because it doesn't go into the 3 and it doesn't go into the 8. It does go into the 8. It has to be able to go into both. Doctor?
Why did you speak of the x squared?
That's the other way. So, the other way, which I know is how a lot of you want to do it, and I'm fine with this. If you look at that, and you just realize that you can divide out of subtraction and addition if it comes out of everything, then do that. Can 2 go into 3 and 8? No, so you can't divide the two. Does the x go into x squared and x? Yes, so you can take 1x out of everything. 1x, 1x, 1x. Leaves you with the same thing, 3x minus 8 divided by 2. Neither method's wrong. That one's faster. This one's a little more safegoating. You'll be okay if you don't remember how to do this. You can just factor in the divide. Zucker.
When you take out that x, you don't have to put it anywhere else, right?
Right.
So,
Exactly. Alright. I want you to do all 6 of these on your own. You got 5 minutes. 10 minutes. Give me 10 minutes. And then I'm going to go over them. Put them in simplest form.
Oh my god.
We're going to go over a couple.
Check my
We're going to go over a couple of these. And if I have time, I'll go over all 6. We're going to go over this one, because it does something weird. We're going to go over that one. It does something like it. So, if you take this one, and you factor the top properly, so it's a difference of squares, you should get 4 minus x times 4 plus x. If you switch those, like the order, you're fine. On the bottom, if you factor it properly, you should have got 2x minus 3. No, it's plus 3, right?
No.
Minus 3? Oh yeah, they're both minus 3. That's all. And the other one is x minus 4. Because that's a good question. Because of the way the question was written. So, if you look at this, it's 16 minus x squared. So the 16, the 4, has to be the one that comes first. Because it's the one that comes first in the question. So you can't reverse those orders. And that's why I want to go over this one. 16 minus x squared is not the same thing as x squared minus 16. Wait, I didn't think that was your question. I thought your question was... Wait, look, I'm getting there. That's what we're about to do. I said you could write these in different spots. I thought that's what you meant here. You could have put this one first and this one second, that's fine. But it has to be 4 minus x, 4 plus x. These do not cancel out right now. 4 minus x and x minus 4 are not the same thing, but they're really, really, really close. The symbols are just reversed. London, how could we reverse those symbols? Yeah, I could flip these. So I could change that to x minus 4, but that means I have to multiply everything by negative 1. So if you factored out a negative 1, it would change the order of those things. So that would change to be x minus 4. With a negative 1 in front now. Because you factored that negative 1 out. So what I did is I went 4 divided by negative 1. What's that? Sure. What's 4 times negative 1?
Negative 4.
Negative 4. That's why I switched to negative 4. What's negative x times negative 1? Positive x. That's why I switched to positive x.
Didn't you just do negative x?
No, that's fine. Negative x plus 4. On the top?
No, like the one that you just crossed out and like times 4.
Yeah.
Like it's 4 equal to x, but if you did negative x plus 4, isn't that the same thing?
That's the same thing, but it's still not x minus 4. That's negative x plus 4.
Oh.
So you're right, you've switched it to the right order, but now you're still not the same. You still have to do the negative 1. If you ever get somewhere where you have the same thing but different symbols, and it's a minus, that's what you can do. Put a negative 1 up front, switch them around. Awesome.
On the bottom, like it says if you factor 2x minus 3 minus 14.
It came from factoring this. So if I factor that, 2 times 12 is 24. I have to add the negative 11. You get it? Now they cancel. Cancel, cancel. You have negative 1 times 4 plus x over top of 2x minus 3. You could multiply it in if you wanted. That's an equivalent fraction.
You have to keep it there though? Or
If you
no?
keep it there, that's an equivalent expression. Those are all the same thing, right?
No, like if you don't put it there, is it wrong?
If you didn't have that there at all, it would be wrong.
If you just have
You either have to have it there or have multiplied it in. One or the other.
put it on the top, just put it in there.
If it was a plus,
That's fine.
4, like 4 plus x, would it just stay as that? Or could you, like, you couldn't do anything with the rest?
That's all you can do. You can't do anything else.
Or can you go plus it?
If you wanted to, that would be an equivalent expression.
Negative 4 minus x.
Yes.
That's okay.
Okay. That's confusing. That's why I wanted to go over that one.
Do it right. Do it right order, and then you add it.
What do you mean do it right in the beginning?
Okay, let's do that.
Okay. I want to talk about this one quickly, because it should take 2 seconds. I was going to talk about it. But we're having trouble with this b squared divided by b5. So this is how I explain fractions and exponent law. Because I like video games with fighting. And this is how I use words. Okay. Your dudes on the top, your bees on the top. They're at a war with the bees on the bottom. You have
Just one quick announcement before the bell rings.
You have 2 bees on the top. They're at a war with 5 bees on the bottom. In war, when you go to fight each other, they cancel each other out. So after the first battle, this one dies, this one dies. After the second battle, this one dies, this one dies. I have nothing left on the top, b cubed left on the bottom. That makes sense.
You're like fighting those.
Okay. Yeah.
That's gonna be me in exams.
This one, right here. And I think you guys are better at this because we did it earlier in the year. The other classes. Okay, we'll just keep going after the bell rings. I'm fine. It's addition. So if you can take it out of everything, take it out of everything. Can everything be divided by 3?
Yes.
3's all cancel out. Can the x's come out? So the x's all come out. You'd be left with 2x plus 4. Because 6 divided by 3 is 2. X squared divided by x is 1x. Plus 12x divided by 3x. 12 divided by 3 is 4. Divided by x is 100.
It's also pretty different. It's like stack 4, it's like 2x plus 4, and then it's 3x.
That'd be fine. That, you could also do that. That's how I would factor with 6x is what I would have done. And then realize that the 6 is all
I know, but like, when you write it, that's
Yeah.
Checking my answer, talking about fractions.
Please move the desk back. See you tomorrow.